So I'm going to go through the alternative method for critical path analysis now. So the first thing that you do is you put a 0 at your start because you always start at time 0. You then grab a green pen and you forward scan, adding the numbers of each edge. So for instance, this will be 9, this will be 15. Now this will be 15 plus 11. So 15 plus 11 is 26. So that means our earliest start time will be 26. And that makes sense because, even though you can do this in 9 minutes, you have to wait until this pathway is finished until you can continue on. So your earliest start time has to be the bigger number. So you're always circling the bigger number in these cases. We continue on. What's 26 plus 7? 26 plus 7 is 33. We can continue on. We'll come back to this 15. 15 plus 8. 15 plus 8 is going to be 23. And then importantly, we've also got 26 coming down this way through this dummy edge. A dummy edge means you're not going to add on anything. So this is 26. Again, you circle your bigger number. So it will be 26. Then you're going to go 26 plus 17, which will be 43. All right, then you'll go 33 plus 6 is 39. You circle your bigger number. Now, this is important. This means that 43 is your earliest completion time. Earliest completion time. All right, 43 is your earliest completion time. Now you want to do your backward scanning. So we're going to start at 43 and we're going to subtract 17. So 43 minus 17 is going to leave us with 26. Now also 43 minus 6 is going to leave us with 37. So that means our latest start time is going to be 37 minutes for this point right here for activity F. And then we keep on going. What's 37 minus 7? 37 minus 7 will be 30. Then we keep on going back. What's 26 minus 0? It will be 26. Now, when you have two numbers meeting at a vertex, when you're backward scanning, you want to circle the smallest number. So opposite to when you're forward scanning. 26 minus 8 is going to end up, what is 26 minus 8 going to be? It's going to be 18, isn't it? So that'll be 18. And then what is 26 minus 11? 26 minus 11 will be 15. So the smaller number there is 15. And then 15 minus 15 is 0. And then we'll come up over here. What is 26 minus 9? 26 minus 9 is going to end up being 17. All right, so now that we've done that, you want to circle your smaller number again. And now we can figure out our critical path. The critical path is simply going to be when you have the same number in and out. So for instance, you got 0, 0, 15, 15, 26, 26, 26, 26, and then to the end. So we've just found the critical path there. All right, now that we've done that, we can answer a few questions as well. Again, these are just taken from Edrolo textbook. This is question 16 if you are curious. So what is the float time of activity A? Now, this is where this method, I feel, really becomes helpful because to figure out the float time of activity A, let me grab another color here. Let me grab black. If I want to find the float time of activity A, I'll come to activity A and I simply want to go 17 minus 0. So I'll go 17 minus 0 is going to be equal to 17. There it is. Find the float time of activity G. All right, where's the float time? Where's G? Here's G. So if I want to find the float time of activity G, what I'm simply going to do is I'm going to go, all right, what is 26 minus 26? It will be 26 minus 26 is equal to 0. And then finally it says find the critical path. And we know that this is going to be B, then C. So B, then C, then... Now we don't include the dummy edge. So B, then C, then G. And that's it. That's how we answer this question. So remember, this is the alternative method. If you were to look at the Edrolo solutions over here, they're going to give you something that looks like this. So let's look at them at the same time so you can get a sense of what we've done a little bit differently here. And then you can choose what you like better. So let's come over here. Let's come here. All right. So here it is. Here it is right here. So as you can see, here's 0, 17. Here's 0, 17. Here is... Now, depending on where you're going to look at it, so 26 and 30. So 26 and 30 is showing me there. And then over here, I've got like 15 and 15. Here I've got, now where's this 15 and 15, 18? 15, 18. Then I've got 26, 26. I've got 33, 37. And I've got 43 and then 43 there. So it's a different way of representing the data, definitely. But I actually find that this is a much nicer ways sometimes. Sometimes, nothing is absolute here, but I find for most cases, this is a neater way of going about it. All right, this screen's a bit of a mess now, but hopefully this has made sense.